Hello, seventh grade. We're going to go ahead and get started with lesson 93. This is a new lesson. We have not done it yet. It is titled Two-Step Equations and Inequalities. And basically what that means is all we're doing is we're trying to look for the missing number. Okay, and the missing number is a variable. Could be labeled as X or T or Q or whatever they want to put the letter as. This case, in example 1, as you can see on the board, it says 0.4x plus 1.2 equals 6. So the missing number or the variable is the letter x. And we need to solve for that. And in the title it says two-step equations. Well, it's going to take 2 steps to solve this number, okay? So what we need to do is we need to get x, the letter x, which if you look, it is on the left side of the equals, okay? We need to move all these numbers. We need to move the 1.2 and we need to move the 0.4 to the other side, to the right side of the equals. And I will show you how we do that, okay? So you start with the numbers that you have to move, the 1.2 and the 0.4. You start with the number that's not connected to the variable, okay? So in this case, we're going to start with 1.2. And you ask yourself, okay, is this a positive 1.2 or a negative 1.2? And if you look right before the 1.2, there's a plus sign. That means that that's a positive 1.2. Okay, so to get that positive 1.2 to the other side, to the right side, you do the opposite. Okay? And the opposite of a positive 1.2 would be a negative 1.2. So we are going to do the opposite. We're going to subtract 1.2 from the left side. I just wrote that's right under the original, a positive 1.2. But you also have to do the same to the left side, minus 1.2. Okay? That side where I just put the x through, that cancels out. Okay? And it's just a 0, which you just don't put anything in there anymore. But now you actually have to do this side. Well, 6 minus 1.2 actually gets us to 4.8. Now you want to rewrite all the numbers you did not use yet. We got rid of the 1.2 because we moved it to the right, and we got a new answer. We got a new answer, kind of, to our problem. We have not touched the 0.4x yet, so let's rewrite that. 0.4x. Now, how do you get rid of the 0.4 on this side? And we want to move it over here to the right side. Okay, well, you have to do the opposite. And it says, if you were to read this perfectly, it says 0.4 times a number we don't know equals 4.8. Okay? So since it said times a number we don't know, you do the opposite to move the 0.4 to the other side. So you would actually divide by 0.4 on both sides. The left side, since you had a times 0.4 and a divide 0.4, that just gets rid of itself. Okay, it cancels itself out. And the only thing you should have left over here is x equals whatever our answer is to 4.8 divided by 0.4. Okay, and we will do that over here. So if I go 4.8 and divide it by 0.4, we would realize we cannot leave it like that because you cannot have a decimal on the outside. You have to move it next to the box part of the division. Okay, and if you move the left one, or the outside number, if you move that one time, you have to move the inside number one time as well. So your inside number should now say 48. Your outside number should say 4. Okay, now it's just 4 into 48, which that's going to be 12 times. And for a final answer of x equals 12. I'll kind of get out of the way so you can see how we did that again. Okay? So what we just did there is we did a two-step problem to solve for a missing number, the letter X, the letter we did not know. Okay, and then we got the answer to it. So we'll do another one, and I think it'll start making more sense. We just added, we've done this before. The only thing that's new is we just added a second step. Okay, so let's do example 2. It says negative 2/3 x and then I think it said minus. Yep, minus 1/2 equals 1/3. Okay. Now, you do the same thing. Okay. We need to get these two numbers on the left side. Remember, first off, how do you know what to do? Find where the variable is. Okay. And if you look, the variable is on the left side of the equals. It's on the left side. So that means every single number on the left side, besides the variable, the letter x, needs to be moved to the right side. Okay, so we are going to move the 1/2, and not just 1/2, but it's the negative 1/2. And we're also going to move the negative 2/3. It's just, which one do you do first? And remember, you always move the number that is not connected with the variable. These two are connected. Or, in other words, you always move this number last. You move every other number first that's not connected to the variable. Then you move the number that's connected to the variable last. Okay, so, and how do you move them over? You move them over by doing the opposite of what the sign says. Now, this sign says this is a minus 1/2. Minus 1/2. So in order to get the minus 1/2 to the right side, we actually need to add 1/2. I'll write that right below it to show that, hey, that's what we were doing. We're adding 1/2, and we're going to do that over here. This side is just going to cancel out. That number's just gone now because we had a negative 1/2 and a positive 1/2. It's just 0, it's just gone. But now we have to add these up, and we need common denominators, okay, which I'm going to make the common denominator a 6. 1/3 turns into 2/6, plus 1/2 is going to turn into 3/6. Okay, and 2/6 plus 3/6 is going to equal 5/6. Now, rewrite everything we haven't used, which we have not used negative 2/3 x yet. Okay, so now, if we were going to read our new problem, it would say, hey, negative 2/3 times a number we don't know equals 5/6, equals 5/6. Well, remember, we need to move all the numbers with the letter, with the variable, to the right side. And you do that by doing the opposite of what it says. In this case, it said times a number we don't know, so we need to divide. So I'm going to write a big fraction bar showing we're dividing by a negative 2/3, the same exact fraction. Okay? And what this does to the left is it cancels those numbers out because we had one that we were timesing, we have one that we're dividing, it just gets rid of it. And on the left side, we're left with just x equals, and then now we needed to solve the problem. Well, the problem is this. It should be 5/6 divided by a negative 2/3. Okay? What do we do when we divide fractions? We flip and times. You flip the second fraction and you start timesing top times top, bottom times bottom. So I'm going to write 5/6 times 3/2, and I'm just going to put a little negative in there. I mean, it still is. So, and since we only have one negative in our problem, we know our answer is going to be negative, and then there's going to be a fraction. So 5 times 3 is 15. 6 times 2 is 12. You can leave it as an improper fraction. I would change it so it's not 15 over 12 is 1 3/12. Because 12 goes into 15 one time, there's 3 left over when you divide that out, and the bottom number stays the same as 12. Now, 1 3/12 is also reduced to 1 1/4. Okay, so the very final answer down at the bottom is 1 1/4. Or, if you wanted to simplify that, you could simplify it like I just looked at the book. The book has 5/4. If you want to leave it at, like I said, as an improper fraction, just reduce this all the way down, okay? And if you reduce, what number does 15 and 12 have in common? Okay, that'd be 3. 15 divided by 3 is 5. 12 divided by 3 is 4. And the book put 5 over 4. That's fine too. I'm fine with an improper fraction. Just don't leave it as 15 over 12 because you can reduce it down to 5 over 4. Okay? Okay, so I'm not going to do example 3 because that's very similar. It's the same exact thing to what we just did for the first 2 problems. Okay, but now I am going to do example 4 because you're going to be asked to do this again. And we've graphed inequalities before, right? And an inequality is it's a way to put a graph out there using a number line, and it signifies that, hey, this has more than one answer. This might have 7 answers or might have 10 answers, you know. Like if I asked you, give me a number less than 15, well, really the list could go on forever because someone could say 5 or 10 or 11 or whatever. And then if we got into the negative numbers, you could say -1, -2, -3. So those are all less than 15. So rather than writing all those numbers out, you write an inequality, okay? And remember, we've done this before. This is not in your book, but I'll just show you a quick example. So if we said, hey, give me a number that's less than 15. Or this one says greater than 15. So I should probably erase that and say, hey, list all possible numbers less than 15. This is how we did it. Remember, we made a number line. We wrote one number in the middle, which we got from the problem. It said 15. We wrote an open circle because there's no line underneath it, right? The line underneath it tells us to fill it in and close it. This doesn't have that. And then it wants us to say, hey, how would you signify all numbers less than 15? Well, on a number line, less is going to the left. So every number less than 15. Can it be equal to 15? No, not in this case, because there's no underline under the less than sign, okay? That would tell me if there was a line under it, that would say, hey, yeah, it can be equals to 15, okay? So that's inequality. Remember, we've done that before, okay? Here is now a step further with that inequality of what you're going to do, okay? And in example 4, it says solve it and then graph this. And it says 2x minus 5 and I think it says greater than, yep, is greater than or equal to 1. Okay, now, all we're going to have is I want you to treat this as the exact same. First, we need to solve it like we did the previous 2 examples, okay? And then at the end, when we get our answer, we'll graph it. So right here, you see greater than or equal to. Treat that as your equal sign, okay? And we need to get all these numbers, the -5 and the 2, we need to move them over to the other side. Okay, and remember, you move the one that's connected with the variable last. Always last. So that means we move the -5 first. And how do you do it? you do the opposite of -5. Okay, well, the opposite of -5 is +5. So we're going to say, hey, we're going to add 5. But notice, if we did it to the left side of the greater than or equal to sign, you also have to do it to the right side. So we're going to add 5 to this side. 1 plus 5 is 6. The sign stays the same. This side cancels out because we have a -5 and a +5. It just means 0. And now we're left with just 2x, which we can rewrite to x. Well, this says 2 times a number we don't know should be greater than or equal to 6. Well, you do the opposite. 2 times a number we don't know, you do the opposite of times, you divide. So we're going to divide by this number, 2. That cancels that side out. But if you do it to the left side, you have to do it to the right side, which 6 divided by 2 is 3. So your final answer should look like this. 3 should be in there, the greater than or equal to, and x. Now, there's your final answer for solving the problem. But now we have to graph it. Okay? So I'm just going to do this over here. How do you know what number to start with? You start with the number 3. I'm going to make a number line with 2 arrows, 1 line in the middle, and I'm going to write the number 3 right there. Now, it does say greater than, but there's also a line under it, and that line under it tells us, hey, we have to actually fill this in so it's a closed circle, okay? Because that's how you signify that when you graph it. So now I know, hey, this is going to be, at least it can be equal to 3. I don't know if it's greater or less than until I draw my arrow. Okay, and we want the number to be greater than 3. Well, greater than 3 is to the right. Okay, so there's actually 2 answers here. This is, it's solved, and then this answer you also need as your answer because that's the graph. Okay. So, we've done this before. There's just one more step. Give it your best shot, and I hope this makes sense. If it doesn't, and we need to go over some answers or some questions on Wednesday or Thursday when we do the Q&A, be more than happy to have you and discuss that then as well. Okay. Remember, Wednesday at 12:30 or Thursday at 2. Okay. Have a good day.